Buckle in everyone, because chances are good these next few episodes are going to be kind of intense, and I apologise in advance for how long there might be between these next couple of episodes. We're definitely in the meat of it now. Today we're going to be making menus. I've covered this topic independently before, so if you see my other video on this, most of this is going to be quite familiar, but we're also going to add some things we need, like the capability for submenus and the ability to scroll down past the bottom edge of the menu. The menu we make today won't do anything by itself, but it will give us the framework we need to select actions for our characters. So first of all, we're going to make a new script called menu functions. Then we're going to make a new function called menu. This is what we're going to call to create an arbitrary menu whenever we want one. You don't just have to use this in the battle system, of course, as it will let each menu option have its own arbitrary function. You could use this for any menu in your game, really. The options will be provided as an array of arrays, with each array in the array being an individual option with a name, function, and any arguments needed for that function. There's also a fourth entry I forgot to include here for an available boolean. That is true if the option should be allowed to be selected, or false if it should be shown but grayed out. On reflection, this would have been better and easier to follow using structs within an array, but I wouldn't change something like that now if you're following along, as it might make following the rest extremely difficult. I just pointed out for educational purposes, the order of this information isn't important and each entry is distinct, which is usually a good sign that a struct would be a better fit. But we are going to use an array because that's what I did. It's not the end of the world. Use it as a learning example of when to use a struct versus an array. If it's not clear now, you'll probably see why as we get further in. So the first thing this function does is create a new instance of an object we'll make later on called oMenu at a very lazy depth of negative 99,999, so it appears above everything else. We give it the options description. The description is something we probably won't ever use in this sort of a leftover from my generic menu system, but it's easier to leave this functionality in for now. Options count is the number of options we have, and visible options max will be how many options we can actually fit on the menu at once for scrolling purposes. For now, we'll assume it's all of them and only adjust if we've specified a fixed height for the menu later. Then we'll set up some margin variables and also set the font we'll be using. It's important to set the font of the menu because we'll be using string width functions that rely on the font being set to know how wide a string would actually be if drawn. We also want a line height, and I recommend setting this manually rather than relying on string height, just because in my experience, fonts can be a bit unpredictable when it comes to height specifically. I'm not sure why, it might even be a GameMaker thing. I just find it's better and more flexible to choose a number for this and experiment with how it looks. Then we want to handle the width of the box if we haven't set one. This will ultimately not matter for our purposes as we'll be setting a fixed width and height, but it can be a useful functionality to have if using these menus elsewhere. We basically set the width to 1 and then loop over each option, including the description if there is one, and continuously set the width to be the max, that is the biggest, of either itself or the current option being checked, so we get the maximum necessary width. Remember, the actual name of each option is in the first entry of each array in our options array. Oh, this really would have been better as a struct, wouldn't it? Oh well. Then we add the x margin times 2 to get our total box width. Of course, if width is defined, which it will be, we just set width full to be that defined value and we're done. For height, we do something similar. If it's undefined, we take our predefined line height value and multiply it by the number of lines we have, plus 1 if there's a description line. This is also a really dumb way of writing does not equal -1, but apparently that's how I did it. Then we add the margins. If we do have a defined height, then we set it appropriately, but also we need to handle scrolling. So we use the same calculation for the height of the box to see if it exceeds the height we picked, accounting for the necessary margins. If that's the case, then we set scrolling to true and determine how many options can be visible at once based on the height of the box. And that's the menu function. Two more small functions in this script before we move on though. We need a submenu function that can be used as one of our menu options when we need to implement a submenu. This takes an options array of arrays, just like in our menu function. What this will then do is store our current menu options into an array called options above, depending what submenu level or depth we're at. Then we increase that depth level and swap our menu options for the submenu options, also resetting our currently hovered option to the top of the new menu. We also then need a menu go back function to let us make our way back up the tree of submenus. Just reduce submenu level by 1 and swap the options array back in from our options above array. Okay, now with that done, we can make the menu object itself. Let's make a new object called oMenu and add the create event first. Here we just set hover to 0, that's our selected option, active to true, this will be used later when we want to temporarily disable the menu while we're selecting the targets for a given action, and submenu level to 0. Now let's add the step event. There's more going on here, so we'll maximize. If our menu is active, we want to control it. I'm only including keyboard controls here and with a very simple keyboard check pressed setup. If you use something like Juju's input library or some other kind of input management, which I recommend for the sake of key bindings and so on, then you'll obviously need to rework this at some point. Anyway, move hover up and down with the arrow keys and wrap it around if it hits the bottom or the top. Or just stop it going off the top or bottom, it's up to you. I've gone for a wraparound. Next, we want to be able to execute the selected action. If we press enter and this option has more than one entry in its array, meaning it's more than just a text string, and the fourth entry, index 3, which is our available flag, is set to true. Again, if we had used the struct here, this would be easier. We wouldn't have to remember what each index was and could refer to them by name and not have to use the number of entries to determine if these things exist. Oh well. Anyway, if those things are true, next we want to know if our selected option contained a function. If it's -1, we just ignore it, but if it has a function, we assign it to this var called _func, and then if there are arguments for the function stored at index 2, we use script execute ext to call the function with that argument passed as an array. You might wonder why I don't just call func, including the argument, but this lets us pass through an array of arguments from this one variable to any function we might want to call that might take in multiple arguments and not in the form of an array. It just makes it more widely compatible with lots of different functions that weren't built with your menu system in mind. Anyway, if we don't have any arguments to pass, then we can just call func and be done with it. Lastly, if we press the escape key and we happen to be at least one submenu level deep, we'll automatically call the menu go back function and go back up a level just for convenience. And that's the step event. Finally, we'll add the draw event and actually construct the menu. Firstly, we'll just draw the box sprite. This is a simple sprite with 9 slice enabled, which means we can draw it at any size we want and it will tile appropriately to look correct without looking stretched. Next up, we'll set our color, font, and alignment as we always should when wanting to draw any kind of text. Once again, I do this very odd way of writing description does not equal -1 and store it into _desk so we know if there's a description to draw. Then scroll push will be set to the largest of 0 and our current option minus the maximum number of visible options -1. What this gives us is how many options past the theoretical bottom of the menu we are. So if we can only fit 3 options at once and we go to option 4, this number becomes 1. We're 1 past the bottom. And at 5 it becomes 2 and so on. This means we can then cut this many options off the top of the menu and show the following 3 or whatever the limit is. That's how our scrolling will work. With that done, we start a for loop going over each line, or L, of our menu, going from 0 to the maximum number of visible options, plus the description if we have one. Now that might mean we actually go beyond the number of options we have depending on the size of the box, so first of all we'll check if L is greater than or equal to the number of options. If so, we'll break and end the for loop early. Otherwise, set our color to white again, you'll see why later, and then if L is 0 and we have a description, we draw it at our X and Y plus our margin. If not, then we get the option we want to show, which is our current L minus whether or not there was a description, plus our scroll push value. Then str will be the string to draw, which we get from our options array, picking the entry using option to show and getting its name from index 0. Then if we happen to have this option highlighted, we highlight it by setting our draw color to yellow. This is why we need to refresh the color to white each loop in case. Then if the option happens to be unavailable right now as stored in index 3 of its array, we set the color to gray. Then finally, we draw the string at our X and Y plus our margins plus L times our height per line. Close the loop, and then we'll also add a couple of other niceties by drawing a pointer sprite. This is a cute little retro finger pointer with its origin positioned so as to make it easier to simply place the sprite at roughly the same position as whatever we're pointing at, and we'll do just that. There are a couple of magic numbers here to adjust it, and the Y position must add the hover value minus our scroll push value multiplied by the height per line so it's in the right spot. Then lastly, if we aren't showing all the options at once and the user is able to scroll the menu, it's a good idea to let them know that. So if visible options max is lower than the total number of options and hover is currently not at the bottom option, we'll draw a tiny down arrow sprite at the bottom of our text box. And that's everything. Now we've done way too much here to actually hook this up to our battle system in this episode, but we can do a satisfying test of it before we wrap up. Let's go to O Battle and make a key press event for the letter M or something temporary and out the way. Then I'm going to paste in this, and you can just copy this directly. It's not really important, it's temporary. It's a menu call at x plus 10 and y plus 10 and provides an array of arrays. This is what our menus look like. Each entry containing the option name, function if it has one, arguments if it has them, and whether it's available or should be grayed out. These options with -1 as the function won't do anything if selected, but here you can see we've set up a submenu for magic. For the argument for submenu, we must provide an array, as that's what script execute ext needs, that contains an array, which is what our menus use, of arrays which represent the options in that array. Easy to accidentally just provide one array here and forget the script execute requirement, so make sure it's a double array like this. Our game will actually calculate all of this for us in the future and build this menu format automatically for each controllable unit, so don't worry too much. I'm just explaining how this works right now. You'll see also we included the menu go back function on a back option in our submenu. That doesn't take any arguments, so nice and simple. If we run the game with this and get into a fight and press M, we'll oh, I screwed up. Turns out I wrote width wrongly in the menu function, easy mistake. I would normally scream with rage at this point and begin recording the whole visual steps of the video again from scratch, but this time I'm leaving it in because 1, I can't face typing all of this out again, and 2, it's educational. You see, it's very common and easy to make mistakes even when you are literally copying from a script, so don't worry, be vigilant and accept how easy it is to make tiny mistakes like this, and I promise you, you'll get it all working. There's a lot of code in this episode, so don't be surprised if this happens to you. I'm sorry if I'm not more helpful in the comments, it's just hard to always diagnose everyone's issues, as it's hard to predict exactly what you might have done and so on. Anyway, congratulations for making it through this one, you're basically committed now, right? The next few are likely to be similarly intense, but really this is the bulk of the system, just actually selecting an action and targeting it. Actually performing the action and progressing turns and ending the fight, etc. Kind of a walk in the park afterwards, so I hope you stick it out. Hope you're finding it helpful. Remember, if you want to support this, you can buy the full source code right now, which I am supporting with extra updates and fixes, and also by supporting me on Patreon if you really like my stuff. Patrons can access the source code too. Speaking of my patrons, thank you to all of them for funding this work, and thank you so much for watching. I'll catch you all next time.